This diagram plots a physical reality built into the foundation of music. If you start from a single note and stack 12 perfect fifths, the most harmonious frequency ratio in nature, they fail to align with 7 perfect octaves. As you can see, the math creates a 1.36% gap. Music theory calls this the Pythagorean comma, a signal that the purest intervals in nature refuse to loop back to a clean starting point. To build instruments that could change keys freely, Western music had to reconcile that gap. The solution was 12-tone equal temperament. As the projection changes, watch how that extending line of pure fifths is bent and welded shut into a closed, evenly divided circle. The 1.36% error is sliced up and distributed equally across 12 semitones. That closed circle allows musicians to modulate into any key without the instrument sounding broken. But there is a physical cost. Because the error is smeared across every note, no chord played on a modern piano is mathematically pure. The frequencies are always clashing, creating a constant acoustic friction known as beating. Thousands of miles away, ancient Chinese musicians ran into this exact same mathematical wall. They calculated the pure ratios, arrived at the 12th note, and saw the 1.36% overshoot. Their response was different. Instead of cutting up the math to force a closed circle, they refused to compromise. This established the primary divide in musical evolution. One side chose the freedom to move through complex architectural harmonies. The other chose to preserve the absolute integrity of the individual tone. To understand that choice, we have to look at how they generated sound. The ancient Chinese used an acoustic law called San Fen Sun Yi. It relies on basic fractions. Subtract a third of a pipe's length, then add a third to the next. This strict formula guarantees a pure 3:2 frequency ratio, completely free of the acoustic friction found in Western tuning. This sequence illustrates why traditional Chinese music relies on the pentatonic scale. By following those first 4 calculation steps, we generate 5 notes: 1, 2, 3, 5, and 6. This early sequence is a mathematical safe zone. The compounding error of the Pythagorean comma hasn't grown large enough to become audible yet, keeping the harmony flawless. There is a common myth that ancient Eastern musicians simply didn't know about the other notes. These are the bronze bells of the Marquis Yi of Zheng, cast 2,400 years ago. Through precise engineering, they contain a complete 12-semitone chromatic scale. They knew exactly where the other notes were. The reliance on 5 notes was a matter of physical constraints. Pitch in a bronze bell is locked into the metal the moment it cools. You cannot dynamically adjust the tuning or transpose keys in the middle of a performance. Because these fixed instruments couldn't change keys anyway, ancient musicians saw no reason to muddy the math. They prioritized horizontal melodic purity over vertical progression. If you only play 1 or 2 notes at a time, the notes right in front of you must be acoustically perfect. So what did those mathematicians do when the 12th note failed to loop back? They just kept calculating. A scholar named Jing Fong pushed the pure 3:2 ratio out to 60 distinct tones. A few centuries later, Qian Leji pushed the sequence to an astonishing 360 tones. This refusal to loop back mirrors the core geometry of the universe. From the rotation of a spiral galaxy to the twisting ladder of DNA, nature rarely functions in perfect closed circles. It prefers the spiral, a path that moves forward without ever stepping in its own tracks. Ancient Eastern philosophy tied musical tuning to the cosmic calendar. Time and space move forward in continuous spirals. A new year begins, but the Earth never returns to the exact same starting point in time. In this view, the 1.36% gap isn't a mistake to be fixed, it's the signature of a living system. Forcing the math to close would mean trading a vibrant, expanding cosmos for a static, artificial loop. Despite that cosmic philosophy, the Western Circle ultimately conquered the globe. Look at these craftsmen assembling piano frames in the 19th century. The physical tension of cast iron pianos, combined with the demands of mass manufacturing, required absolute standardization. Equal temperament became the global default because it was the most efficient engineering compromise for physical instruments. But the human ear's desire for pure resonance never faded, and today, the digital age has finally removed the physical constraints of bronze bells and iron piano frames. This flowchart illustrates how modern synthesizers accomplish this. Sound generation is now broken down into 3 distinct software components. You have MIDI providing the logic of which key you press, you have physical modeling simulating the acoustic flesh of the instrument, and finally you have a scala file, a small piece of code acting as the tuning soul. By isolating the tuning data, a musician can press a standard piano key but tell the software to output a 53-tone scale, or the ancient San Fen Sun Yi math. The software dynamically maps the perfect 3:2 ratio onto the keyboard in real time, erasing the Pythagorean comma without sacrificing a single pure interval. For 2,000 years, humanity had to choose between the freedom to move through complex harmonies and the absolute purity of a single note. Today, by decoupling the physical instrument from the mathematical tuning, we no longer have to choose. We no longer have to bend the spiral into a circle.